So here we've got a question regarding this equation. We've got cosec of 2x equals 4 minus x. And I'm going to draw a graph of it on here, what happens with this equation. And we're going to find the smallest solution, which we're going to give the value name of a. So that's going to be somewhere on here. Now, first of all, let's have a look at this left-hand side. 4 minus x, that's not going to be a problem to sketch that. But cosec 2x. So cosec 2x, that's going to be the equivalent of 1 over sine 2x. Obviously, cosec is the reciprocal of sine. So that's what we've got. So we need to try and, first of all, create some sort of graph of cosec 2x. So let's do that. So first of all, if I start from sine of x and then progress to sine of 2x, that'd be my first easy way of doing this. So sine of x has this kind of sketch like this, doesn't it? So we've got local minimums and maximums here, and we've got our zeros here. Now the zeros of sine of x, they occur every pi. So that's obviously a 0. If I just write them along the bottom here, so this is at the origin, this is my x values. Here I've got this one here, that's at pi, and this one here is at 2 pi. So that's all my zeros. I've got a local minimum here, sorry, a local maximum here. That's obviously at the value 1. These ones at the value minus 1. These ones will occur at pi over 2. So there, if I just write these ones up here, I've got pi over 2. So obviously here, in between pi and 2 pi, I've got 3 pi over 2, sorry, 3 pi over 2. So that's those. So that's my zeros, and that's my bits there, which are my local minimums and maximums. So that's that point there and that point there. And obviously the negatives are on this side. So now, if I'm doing sine of 2x, I can then, that will incur a squeeze. So if I change this graph now to sine of 2x, this will stays at 0. This will all divide by 2. This one will divide by 2, which becomes pi. Then divide all of these by 2. I've got 3 pi over 4 and pi over 4. It's probably the easiest way to transform that graph in terms of a squeeze or a stretch in terms of a factor half. But now what I want is cosec. So let's have a look at cosec. So if I draw my cosec on here, because if I do this, 1 over that is my cosec. Obviously just repeating what we've got here to use our transformation. If we take the reciprocal of this, when sine of 2x is 0, we're going to have asymptotes. So our asymptotes are going to be at the point where this graph crosses the x-axis for its reciprocal the other way around. So that's my construction line there. So here the graph will not exist. So here I've got my local maximum. Now a local maximum for sine of 2x will become a local minimum for cosec 2x. Now if I do 1 divided by my 1, I still end up with 1. So that will be at that point there. That's going to be a local minimum. So in which case, this graph is going to go something like that, just as a bit of a brief sketch. And here I've got a local minimum. So the reciprocal of minus 1 is going to be still 1 over minus 1, which is minus 1. So that's going to be here. But instead of becoming a minimum, this is now going to become a local maximum. So this graph is now going to follow this trajectory, and so on. So that's my cosec of 2x drawn on there. So let's just pop that on here now. So let's just get first 2 in. So obviously we want the smallest value a, so we don't need to go too crazy. So just put that one there, and then that one there. Let's put our minus 1, sorry, and plus 1. So then let's sketch these ones in. So then we're going to have something that goes a bit like this. Obviously it's a sketch, so we're just trying to get a general picture. That's that one, and then same here. So these ones go something like that, and then something, oh, not too far low, I need to go adjacent to that one. So that's something like that. So that's the cosec one. So now I need to do the graph of 4 minus x. A bit more straightforward, just a linear. So if I just mark my points 4 on here, that's going to be somewhere here, let's say, and somewhere here. 4 minus x is going to cross somewhere like that. maybe intersects this one, I'm not too sure. But anyway, this line, that's what it will look like. And as we're looking for the smallest value, we know we're looking at this one here. So that's going to be our point A. Now, what we can do to find that, to solve this, is going to need numerical methods. So we can use something called the small angle theorem. So if I think of x, let's just write it here, sine of x in the small angle theorem is just x. But we want to find it in terms of A. So what I'm going to do is now just change this. So sine of A is equivalent to A. Okay. Now, just one quick word on this graph. You can see here the line of 4 minus x. Let's just write that up here. 4 minus x. That's that one. And then I've got cosec 2x in the blue. So we've got that one written on there. Now we know, if we look at this graph, there's going to be infinite solutions because this will be repeated forever along here, and these lines will go down to negative infinity. Here we'll go up to positive infinity. So those lines will go on forever. So 4 minus x will intersect this particular graph at infinite places. Okay, now how to find our minimum value. Now it's going to be an estimate because we're using the small angle theorem. So the closer you are to the y-axis, the more accurate it is. So this one here probably be less accurate than what this one is. So to do that, what I'm going to do is I'm going to plug it into this equation. So sine of A equals A, in which case sine of 2A is equivalent to 2A. That's using the small angle theorem. But I've got cosec 2x, which is 1 over sine 2x. So basically I've got 1 over 2A. So 1 over 2A, that is equivalent to 4 minus x. Now I've changed my variable for x. I want to use A. So that's equivalent to 4 minus A. So now all I've got to do now is solve for A, and I've got my small value. So just now into our algebra, multiply both sides by 2A. So multiply by 2A. Times this by 2A, I just end up with 1. So let's bring this up to here. I've got 1. Multiply this by 2A, I've got 8A. And multiply this by 2A, I've got minus 2A squared. And now I've got something that's in quadratic form, and I'm going to get my two solutions, which is probably give me this one and this one. So this one and this one will be my other solution. So I'll call that A prime. So now let's turn it into a quadratic and let's get a solution. So 2A squared minus 8A plus 1 equals 0. Now it doesn't look obvious to me that that factorises, and it's very unlikely, so I'm going to go straight into the quadratic formula. So A equals, well, my A value in the quadratic formula is 2, so assume it's that. And then B equals minus 8, C equals 1. So this is not the A for the A in there, that's just my coefficient there. So minus B, so A equals minus B, which is minus minus 8, so that's 8, plus or minus square root B squared, which is 64, minus 4 times A times C. 4 times C is 4, times A is 2, so 4 2s are 8. And then divide by 2A, which is 4. And then what I can do is now, let's get our solution for this. So A equals, divide everything by 2 there. So I've got 8 plus or minus. So I can divide by 2, or divide by 4 actually. What have we got? Square root of 56. Let's just a quick value on the surds. 56, and take a 4 out. So square roots of 4 times 14. So I can take a 2 out. So square root of 4, which is 2. So I've got 4 plus or minus square root of 14, all divided by 2. Now the smallest value, square root of 14 is just under 4. So 4 minus that will give me a small value divided by 2. So in which case my smallest value will be A, 4 minus square root of 14 over 2. Now if I plug that into my calculator, I get approximately 0.129. And that would be my A value here. So this value here is approximately 0.129. So that's the answer to my question. Solution A, which is approximately, let's put that as approximately 0.129, and then we are done.